Welcome to the course on wheeled mobile robotic. So this is actually like very broad course, but we are trying to restrict that mobile robot into a wheeled configuration. So in that sense, this course, if you actually like a takeaway for 8 weeks, you would be able to understand basic concept to the end prototype. This is the overall idea. So this particular course would be having at least you can see 8 weeks. In that go, you can see that the locomotion we will cover first, then the sensing, navigation, and finally we'll start and end with the control. This is what the overall flow. So this is the first lecture on introduction to mobile robot and manipulator. So this is actually like very broad, you can say spectrum mobile robots. So in that we are actually trying to restrict to the wheeled mobile robot. So I'll be introducing what is mobile robot and what is wheeled mobile robot in this particular lecture. So before going to that particular aspect, so let me actually like give a small note. So this particular course intended to teach only for educational purpose. So that's what this note or disclaimer all about. So let us start the lecture 1. The lecture 1 would be having more, you can say broad, you can see it's a basic introduction. So we'll be talking about what is robot in the perspective of effect. So which is nothing but effector. Then we will be talking about types of effector. Then we will be seeing on the themes of robotics. Then we will move to the original core, which is mobile robot. So there also we'll start with a basic question and then we will see what are the components will come into mobile robot. So if we go this way, so as I already told, so we'll talk about the robot as a general term called effector. So what is effector? The effector is nothing but a you can say robot or robotic device that has an effect on the environment. This is what we are going to call as a effector. So now you can see that any robot, whatever you talk in real time, these all actually like what we are bringing to a effector. So now you can see that this effector can be broadly classified into two categories. So one is based on the effect of the environment. Now you can see that the effect of the environment or effect on the environment causes motion of the effector itself. So then what we call this particular motion called locomotion. So now whatever the locomotion happening, that is what we call a general broad way of we can say classify as a mobile robot. So this is what I am giving in this particular definition. You can see the locomotion is actually like I am giving in another way of definition, that is based on the effect of the environment. So now you can see if the effect on the environment causes motion of the effector itself, this is what we simply call locomotion. And the locomoting device what we call mobile robot. Now the contradict what would be coming, so the effect on the environment causes motion of the object around rather than the effector itself. So this is what we call manipulation, and I put the color red in the sense the manipulator, what you call the manipulating device, which is actually like very well saturated and matured field, and the mobile robot what we are going to focus in this particular talk or particular lecture and course, that's why I put that in the green. So now you can see that this is the way we are actually like classifying and defining the robot. So now one thing can come in our mind. So then what is the meaning of control? Control also as a effector or not? So in that sense, what our perspective, the controller or control is not a effector, that is a aiding tool, or you can say what generally it is actually like assisting device. So that is what we are trying to say. What exactly this does? So the role of controller is to get the effector to produce the desired effect. That is what the you can say important thing. So you are saying that the effect on the environment may cause the motion of the effector or cause the motion of the object around. So now this particular predefined way, so how that motion or how that would be enabled, that enabling mechanism what we call controller. So in that sense you can see that the controller is not part of effector. That is what this whole slide talking about. So now we will move further. So you have already classified the effector into two broad, one is manipulator, the other one is mobile robot. We will talk more about you can say these in detail. So what that means? So the manipulator means it is manipulating the object around. For example, I take my arm, this arm is actually like manipulating the object around. So in that sense, what one can see, the effector, which is nothing but manipulator, is actually like fixed in one end. So it can be actually like have a multiple arm connected with a mobile base, or it is actually like single arm which is actually like open space. So the open one we call serial manipulator. If it is actually like connecting parallel chain with the mobile base, that is what we call parallel manipulator. For example, now I have two arms, this is actually like individual serial manipulator, but now I combine this is actually like giving the parallel manipulator kind. So now that is not the you can say important in this particular slide. This particular slide says that this manipulator is actually like fixed. So because of the fixed, what we can actually like see, the operation would be happening in a constrained workspace. So that is what more important. Whereas the mobile robot is not constrained. It is actually like can operate in a unconstrained and unstructured environment. This is what the basic difference. So now based on this basic difference, what are the things will come? So now it is actually like the manipulator is working on a constrained workspace. In the sense the manipulator can be easily pre-programmed and actually you can put a fins covered. So then you can see that the interaction is actually like very much restricted. So in that sense what one can see, the absolute measurement of the position or the robot is easily obtained. Whereas in the case of mobile robot it is not happening. Why? Because the mobile robot is actually like moving on the unstructured environment and as well as you call the unconstrained environment. In that sense, so the robot supposed to understand its own position and as well as it's supposed to understand the, you can say, environment around. So in that sense you can see the manipulator does not require that. So in the sense may or may not need the perceive the work or the world around them. Whereas in the case of mobile robot, it required external sensing for, you can say, measure its own position and as well as the environment itself. So this is the basic difference. So now you can see that, so one of the challenging thing is the mobile robot, but now one thing immediately come into our mind. You see this is also like having a constraint and this is also having some constraint. Can I actually like have a combination of these two where both the pros can be combined? So this is one of the easiest idea which anyone can thought about it. So this is what we are also going to call as a mobile manipulation. In the sense you take this arm and put it on top of this mobile base. What you will get? So the base will give a locomotion and the arm will give the manipulation. So this is what we are actually like calling as a mobile manipulation, which is actually like the system offer both advantage, in the sense the dual advantage of having a manipulability and as well as the maneuverability, which is nothing but what you call locomotion and what you call the manipulation. So in that sense some of the people they call the manipulation capability, we simply or some of the general people call as a dexterity. So that is what I put it in this particular slide. We will discuss more detail about what is maneuverability and dexterity in upcoming lectures, but right now you can actually like understand if you bring it to a mobile manipulation, this would be giving a dual advantage. Further what it gives, so you will get an unbounded workspace, in the sense unlimited workspace for the manipulator because the manipulating device on the top of the mobile base. So this is what one of the simplest idea, which is what you call general category called mobile manipulator, because this is on the mobile base, the manipulator on the mobile base. This is the roboticians, or you can say the field of mechanical side, these systems we called vehicle manipulator system. Okay. So this is not new to us because you would have seen several of us would have seen the construction side or road, you can say laying side, you would have seen there is a earth movers we simply call. The earth movers usually have a backhoe, so which is nothing but the mobile base where the wheeled locomotion would be attached with one of the, you call the manipulator arm, that is what we are going to call as a vehicle manipulator system. The understanding of vehicle manipulator system is very, you can say little tricky, so that we would be addressing in the end of this particular course. Okay. Let us go to the other side. What other side? You know, like robotics is not a new field. It started probably in mid of 70s and it started maturing in mid of 80s. But what one can see, the theme of this robotics is not at all changed. So what that mean? So the robotics theme is actually like still there are two broad themes. One is to enhance the humanity, in the sense increasing the human life and human style or lifestyle, or assisting the human being. The other side is actually like increasing the efficiency or increasing the productivity of the machines. So now in this broad category what one can easily find, so one would be supposed to be a human friendly robot, which would be human and robot interaction. The other side machine and machine interaction, some cases it will come as the human machine interaction. But one is actually like talking about cost and economic and as well as production and you call the resource utilization. The other side is actually trying to see the value of the human. So now in that case, I will just give a very simple example before going to the slide in detail. So for example, you take probably 10 or 20 years back where the kids would be grown in some kind of, you can say even cities or village. So the particular family will be having at least 4 or 5 adults and 3-4 kids, and all the neighbors would be a relative of the same family. But now the scenario has changed, right? Even further the scenarios keep changing. For example, the husband wife work in one of the firm or employ employer, the other you can say spouse would be working in another employer, and the kids would be staying even in some kind of residential campuses, and they used to meet once in a month or once in a semester or once in a year. So these all actually like change the lifestyle. So further what one can see, so even after 40 or 50 years, so you can see like, I'm not saying that from now, the person who is having 40 or 50 years, so they need definitely some kind of, you can say, company. So that company usually like missing in the current perspective. Further you can see that we are all actually like brought into nuclear family. The kids need actually like peer group attraction. So these all happened in the olden style, would come with a pet animal. But most of the residential campus, or you can say residential complexes, they actually like restricted no pets allowed, right? So in that sense what one can see, we can actually try to imitate the pet into a device. So this is also another way of bringing the robot as a companion. So in that sense what one can see, the two broader theme, one will be talking about you call human friendly, the two like companion. So the other side, I just talk about this in a broad way. The industrial cell, earlier it was a fixed. For example, I talk about a car industry. This take probably like 20 cars in a day, then it would be automated. Now even that scenario changed. Now you take a probably a you can say Volkswagen a Classic, or you take a BMW and all, you can do a customization. So now this customization giving, then the work cell what you are having it need not to be fixed. The work cell is supposed to be flexible. So now in that sense what one expecting from the robotic side, so the work cell is supposed to be a smart cell. So what that smart in the sense, it should be intelligent. So these are the two aspects what bringing that overall robotization into two broad category. One is actually like human friendly robot, the other one would be industrial oriented robot. So this would be actually like you call smart autonomous industrial robot. The other side is human friendly, which is what I call companion. So now coming back to the slide, you can see this particular picture would be actually like giving a small idea what is all about companion. So the other side you can actually like see that this is what the smart industrial robot, what I mean to say. You can see that this work cell is actually like no longer fixed. For example, the pallet you can see handling, or you can say something like manipulation, all actually like happening with the help of, you can say, mobile manipulators or mobile robot. In the sense the work cell is need not to be fixed. So now with this two broad theme, one can immediately brought into a question before going to the course. So what would be the question? Sir, when and where to use a robot? This is one of the biggest question, right? So because robots are actually like growing faster, but you should know when and where to use. So this is what we are addressing in this particular, you can say, slide. So what that means, when the robot started evolving, people brought some classes. So what some classes, they asked, okay, there is some thumb rule we have to brought so that the robot can be employed in the industry. So what are the thumb rule they brought? They brought 3Ds. So which is nothing but we call traditional 3Ds. What that says, the environment is very dull or dirt or dangerous, then we can employ the robots. It is actually like quite, you can say, convincing to everyone. But what happened, this is not convincing to the robot industry. What they say, no, this dangerous, dirty and dull, you restrict. Our production may not be actually like go up, and as well as the industry also may not get that perspective. Then what they brought one additional D, what they call conventional 4Ds we brought. The thumb rule added one more D, which is nothing but difficult. So what that means? So the difficulty is actually like nothing but the task can be obtained or can be achieved by the human operator, but that is difficult. So that we can employ the robot, this is what the case. Still the industry people, or you can say the developed countries, were not convinced with this 4D. Then they brought, instead of difficult, they brought one more D, which is what we call dear. So what that means? Dear means everyone immediately thought about it, it is close to us. Yes, in one sense, but no in other sense. What no in the other sense? The industry is looking, dear means whichever is giving economic benefit or profit benefit. So if any system which is actually like making economic benefit, that particular system called dear. So now you can be cautious, any industry or employer is calling you as a dear employee or dear person, then you should be cautious. So you are actually like profit oriented. So you are actually like needed for making some profit. That is what the whole idea. So then you can see that now the industrial robots are not the only which is actually like evolving. Lots of domestic and service robots have come. In the sense what this modern 4D is not restricted And if you are actually like applying to a domestic or you can say flexible layout, these 4Ds are not sufficient. Then what properly brought it, the current trend, so they added one more D and they taken the DR out and they brought domestic, which is in the sense you can apply into any you can say domestic application, and other sense what we call the flexible. The flexible we brought into another D called dexterous. So now you can see that the right side as the core, so what we call the three pitches what mentioned, these are the three core Ds, but we added other Ds just for our benefit to brought the robot in. These are the cases. Now you can get idea when and where to use robots, right? So now we will move forward what we intend to teach in this particular course. So this particular course is all about wheeled mobile robot. So definitely you should know what is mobile robot. So you know already locomotion. So now we brought into the way of locomotion. The mobile robot is an automatic machine that is capable of you can say locomotion. This is what the very simple one line definition. So further you can actually like add some other definition. For example, you can say that the mobile robot means that have the capability to move around in their given environment, that I am adding their given environment and are not fixed to any one physical location. If anything is coming under this, then what you call mobile robot. So then what, then the robotics evolved, because mobile robotics means it is a study of this particular science, or you can say study of this particular area. So then it covers all kind of mobile or mobility, right? The mobility can be like wheeled, which is nothing but roll, or it can be a legged, then that can be called as a walk, or it can be fly or swim. The swim can be underwater or on the surface of water. So in that sense you can see that the mobile robotics very broad. I cannot actually like cover in only 8 weeks. So in the sense what we are restricting to the roll motion, that is what we call wheeled. Okay. So in that sense what one additional thing, I am just recalling the same thing. The mobile robots can actually travel on the ground, on the surface of you can say bodies of water, underwater, or in the air, or even you can say in the space. But right now what we are intent to here talking about, this is definitely a contrast between the fixed base manipulator. How it is actually like different, definitely you know already based on the definition. Further what the difference is, the limit or you can say the use of sensor. So earlier the mobile manipulator what we discussed, that is combination of these two, but what is the manipulator? The manipulator is in the fixed. So in the sense even a small encoder or the potentiometer of individual joint can give a accurate measurement, but in the case of mobile robot that is not possible. So you have to depend on several sensors. In the sense what one can see, you need to use more and more sensor, and the system is actually like employed in you can say less structured, in the sense unstructured or less structured environment. So this is what the overall, that is why we are focusing in this particular course more on this. So in the sense we are going to talk about sensing, perception, navigation all in the overall go. So now before actually like going to talk about this, so I am just giving a mobile robot as a basic question. So in order to understand this basic question, I am actually like giving one simple example. The previous slide is all about that. So what that example, so now imagine I am actually like a Korean, just imagine. So I am a Korean, I am actually like know only English for writing and reading, I do not know how to speak, but somehow actually like one of the joint project with IIT Madras invited me to do some kind of you can say execution. So for that the IIT Madras professors already said that, so your guest house is booked and your travel arrangement all booked. So you get down at the Chennai airport, you would be seeing one placard called your name and you can actually like reach them, then they will take to the guest house. So you do not worry. However, I am sharing the road map just for your understanding. Then what I did, I just took this road map in a Google and then I am actually like checking on the you can say satellite image and I am seeing what are the nodes. So the nodes actually like giving several landmarks. So I am actually seeing the landmarks, you can say taking that landmarks on the road, and I am taking into Google picture and see what the landmark all about. For example, if I take the metro station of the airport, I see how look like, and Katipara you can say junction, if I look how the bridge look like, all those things I am actually like visualize just for my own you can say benefit. Probably you imagine I am a conservative person, I am trying to understand. In that sense you can see there are several landmarks come. So now the scenario is coming like this. So I took the flight, I got down at Chennai airport safely, I took my luggage and I am coming out of the you can say arrival gate. So before looking at the driver, some you can say 4 or 5 gundas actually like took me and put it in the car with a blindfold, and they are actually taking out on the road, fortunately in the same road what I supposed to do, but later on they realize that I am not the person supposed to be taken out, so they just throw on the middle of the road. When I actually like unfold, so what I would see, first I will localize, right. So now I am actually like looking at the Katipara junction where the flyover is looking like that. So then what I can immediately recognize, okay, this is a landmark which I have already recognized, okay, now I can see. So if I go straight, I can actually go to Guindy, and then I can take a probably right turn, and then I can go to Cancer Institute and then take the, you can say, immediate landmark which I supposed to go. But what we are actually like seeing that the landmark is giving all the idea, right. So now imagine the robot. Robot is, you can see, right, it is one of the mobile robot I put it. So this robot does not know this, right. So what we need to give? So we need to give all the information. So in the sense, the robot will ask 3 basic questions. First basic question, when you unfold, what you are seeing is where I am, right. So that is what the first question which is supposed to know the robot, in the sense it is supposed to localize itself. So it is supposed to localize and say, oh, I am here, okay, then that is fine. Then I have to understand where am I going, in the sense I need to see what is the target of this particular robot. So then I will see how to go there. So in the sense, the third question is how to I get there. So now in the sense, you can see process of these 3 questions. So you need to actually like do several things. So all the things I am putting as a 3 different answer. One is definitely you have to make measurement. Based on the making measurement, what you can see, you can perceive the environment and as well as localize yourself, right. So that is what we are actually like saying. So you will model the environment, localize yourself, then you will actually like plan the execution path and then execute along with the motion, right. So these are the cases. So now you can actually get the idea, right. So now what in this particular slide is giving, so whether am I actually like addressing these questions in my course or not. Yes, we are actually like addressing all the questions, and on top of that we are addressing further more. That is what we are actually like trying to see, in the sense what one can see. So the robots are actually like coming with, you can say, mechanical system and as well as the, you can see, electronic and computer based system. In the sense you have to see what are the pillars of the robots, or what are the 4, you can say, founding or bounding and binding blocks. So in the sense what one can see, I am just giving a very simple example before going to this. You imagine, so you are actually like selected for a race car, or you can say for a car race. So now the race car is given. So now what that race car will give? The race car will give the mechanical system which you can take part into the race. So in that mechanical system you can see further things. So there would be a driver line, and you can see that there would be an engine, all those things like. So now you can see what that gives, the mechanical aspect of the overall execution, you got it. Now further what you need to know, since it is a race, so you need to know like what would be the mission, what would be the roadmap. So these all actually like what we are calling as a guidance. So the overall mission would be given, okay, this is the layout, you have to go this way and you have to stop here and you have to take something and go back on this lane, just I am assuming this way. So now what you can see, you need to have some guidance where to go, how to go. Further, even in that guidance, you need to have something like navigational aspect. What that means? You have to perceive your environment. For example, you have adjacent, there is another car, and you have actually like there is a block which is actually like unexpectedly put it on the road, and there is a right sharp turn. You need to understand all those things. So in the sense, you have to sense, perceive and as well as navigate accordingly. For example, you put in your navigational system, you put point to point location. What it will give? It will give the road, right, or the route. But that route is not sufficient. What you need additional, you need to have a guidance. On top of that, there is supposed to be one executor who is called the driver, right. So in the sense what the 4 pillars on the robotics all about. So the mechanical system along with the actuation, that is one of the primary part which we simply call locomotion system. This is what we are going to cover in the first few weeks. So later on we would be talking about the navigational, which I am broadly localization and mapping. So these all will come into a second block. This we would be covering 4th week onwards. Then we would be talking about motion planning and guidance, and finally we would be ending with motion control. So now you can see these are the 4 pillars, right. So how these 4 pillars would be addressed? So based on that you can actually see what are the components will come into a mobile robot. So obviously the mobile robot would be combination of both hardware and software. But here what we are insisting, the component means the physical hardware. So what are the hardwares you will be expecting? So definitely the locomotion system, that is you supposed to know. So in the sense how the robot moves through its environment, that is what you call locomotion here. So then the sensing device is supposed to be there, how the robot measure the properties of itself or properties of the robot and environment, and then reasoning or perceiving system. So based on the you call sensing, the map will be generated and you would be actually like taking further action based on that. So then what one can see, so when the execution would come with the control, so how the robot execute its, you can say, planned actions. So further what one can expect, the communication, right? So the communication is actually like optional if it is autonomous system. Even then also you have to provide some kind of communication, otherwise when you launch, when you take away, these all required, right? In the sense what one can see, the communication also like important in the sense how the robot communicates with an outside operator. So, but these are the you can say funding or you can say building blocks, but what we can actually like say that the robot system consists of two things. One is the body, the other one is brain. So now we are focusing in the first few weeks about the body. So later on we would be talking about the brain. In the brain we would be talking about navigation, guidance and control, okay. So now in that sense, what mobile robotics in general, what are the blocks would be covered in that particular course if you look at. So one is actually the locomotion, which is involve the mechanisms, kinematics, dynamics and motion control. The perception, which we talk about sensing and you can say processing, all those things, signal processing, and finally you would be taking the navigation. Since the guidance and control in robots, we can actually squeeze it into navigation. That is why I put these three blocks. So with that you can see this is the first lecture is ended. So the next lecture what we are going to talk about is more about the locomotion. So the types of locomotion, in that we will be seeing what is wheeled locomotion and we would be focusing on the wheeled locomotion in the lecture 2. I hope now you get a you can say clarity on what is mobile robot and how we are going further in the course. So in the sense we would be talking first the locomotion, then we would be talking about the sensing and navigation, finally we would be talking about the motion control and intelligent aspects, right. So with that I am actually closing. See you in the next lecture. Thank you. Bye.